Let's get started. Hello, and welcome to this session. Good morning, good afternoon, good evening, wherever you are. Thank you for joining us for this session on sensor data. My name is Yogi, and let me go ahead and share my screen first. My name is Yogi. I'm a Principal Solutions Engineer at Yugabyte. And this is just a revision on the title, Fun with Sensors Data. After all, we are at Distributed SQL Summit, and we ought to discuss about data more. As I mentioned earlier, I'm a solutions engineer at Yugabyte. I live in Singapore. I have been working with clients, partners, independent software vendors across the region here in South Asia. I've been a software engineer since late 90s, and I'm also active in the cloud native community, whether it is Yugabyte, Spring, Java, Kubernetes, and my personal blog is at yogendra.me, so do visit it. In past, I have worked at places like VMware, Pivotal. Prior to that, I have worked extensively in the engineering and architecture role in financial sector with companies like Standard Chartered Bank and BlackRock. Why did I choose this topic on IoT data? I'm a hobbyist when it comes to IoT. I try to actually automate things at home, including things like lights. I use Google Home to automate television and lights and curtains and all these things, right? So that actually got me interested in the IoT in the first place. Much like everybody else who probably starts their journey, I have worked on things like Home Assistant and also created a bunch of bots for some automation work for IoT again. Also, we are seeing more and more IoT-based applications evolving or getting introduced in the ecosystem. Every enterprise is running with some sort of IoT project. It's most prominent in the public sector, but even in the private sector, we see a lot of applications based on IoT. In automobile industry, we see a lot of things happening in the IoT space, but even in some of the areas where we don't expect IoT to be as useful, we'll be surprised at the applications that it has. But we are at the Distributed SQL Summit. So how does it relate to Distributed SQL database? Well, the IoT data, much like any other data, requires consistency. It has a higher amount of velocity and volume. So unlike our typical transactional data, the IoT sensor data are typically more ephemeral. They are good for certain number of seconds or minutes or hours or maybe just few days. After that, it's probably best to sort of summarize it and then store it. So again, there is a data lifecycle involved here. And hence, I thought it would be best that we discuss the data lifecycle and various data pipelines that you could actually create using a distributed SQL at the core of it. The definition of IoT is pretty broadly defined as physical objects that have processing and computing power, are attached to sensors. They are sort of providing some sort of substitution for human senses, hence the word sensors. They could provide you with data which is analog or digital. Analog data is most of the time these days getting converted into digital data. And actually we use techniques to capture visual, audiovisual, and other numeric data. It could be weather data, biological data like heart rate and touch-based data, and things like these. The applications are tremendous. You see IoT being used everywhere these days, from the fridge to the car to the aeroplane to your phone has a lot of sensors on it, right? It is pretty much at the heart of the IoT revolution, as I would say it. Now, one thing that caught my attention very early on working with IoT is what is the messaging or what is the communication protocol that IoT is actually using to work with each other really. So MQTT is the standard of IoT messaging. So it has been made popular. It has been popularized by some of the leading companies in the area. It is a message-oriented protocol, and it is based on a publish and subscribe model. So every sensor will publish the data, and it will be controlled through control messages. It is based on TCP/IP. So if you are familiar with computer networks, it's not very far from that. In fact, the brokers that are sent a part of the whole MQTT ecosystem is a TCP/IP broker, which you can simply run on a laptop to test out things. We'll see one of that in the demo later. And also, we find that typically these brokers are backed by a messaging system. So Kafka and RabbitMQ, they are popular examples of this. And each of these things, like there are messaging systems that can even support MQTT broker capabilities. But for most part, I try to actually imagine them as two different systems. As I mentioned earlier, the growth in the IoT sector has been quite phenomenal. If you see the numbers and the charts here, you can find that since 2018, the market size has almost doubled. And even not just the value of it, but even the number of units. If you see across the board in all the sectors, we see a very steady growth year over year. So this is actually a good sign of things to come. Hence, the data revolution that is happening within the IoT ecosystem. When you're going to have more and more sensors, you're going to produce more data. The moment you have more data, you have more challenges with the data. What sort of challenges? Well, scaling, resiliency, automation, and the data lifecycle management. These are typical issues that are actually relevant for not just IoT, but also applicable for data in general from any other source in any other ecosystem. The IoT data lifecycle has some unique criteria which make it a very good candidate for distributed SQL. Because IoT application deal with people's perception or people's expectation out of the system, you need the data to be geo-distributed for acquisition as well as consumption. So just imagine you using a temperature sensor at home or using a thermostat at home, and it is actually producing the sensor data, which gets collected, gets stored on a central server, but you want to see the temperature on your phone. So the acquisition is at the edge, the consumption is at the edge, but the processing could be actually centralized. Now, because we are dealing with people's data residency is also a concern. So how do we tackle that? Through something like YugabyteDB's geo partitioning of data. Data purging is also something important for IoT because, as I mentioned earlier, the data by nature in IoT ecosystem is ephemeral. So the data could be good for a few seconds, few minutes, or few hours, or maybe a day. But post that, you need to purge the data. So in your pipeline, you need to have the right level of criteria for purging of this data in all layers. Now, when it comes to the architecture of these systems, the IoT's architecture, you will find that this is something that people use as a very bare bone architecture. I mean, as an enthusiast, this is what I have been actually using. So I have a Raspberry Pi, which is the core of my IoT ecosystem. It has the processing engine, it has the MQTT broker, it has the database, everything is on it. And then it actually acquires the data from a bunch of these ESP32 chips, which are microcontroller chips embedded on a dev board. I actually hook up a lot of sensors to these dev boards. Here, what you could see is this sensor could potentially have your temperature sensor or humidity sensor. Sorry, this SoC or this board can actually have your humidity and temperature sensor, whereas this might actually be hooked up to an infrared controller. So the moment the temperature near my bed drops above or goes above 26 degrees, well, my air conditioner could be turned on. And that is perfectly okay. Obviously, a lot of air conditioners come with their own thermostats and all, but hey, enthusiasts are enthusiasts. We'll do it this way. So let's look at a very basic demo of how MQTT actually works. Okay, so for the demo, what I'm going to do is I'm going to have a virtual device. Really, it's a Python script, right? And what it does is that it actually publishes its sensor state. We call it sensor 3542. I mean, just a random name, really. It publishes its state, whether it's on or off, to a status channel. And from the status channel, it is subscribed by a display module, which just shows whether the sensor that we are interested in, is it on or off. In order to turn it on or off, we actually can send a message on the control channel here through a switch program, which will be received by the same virtual sensor. And this sensor state would actually be changed. And you would actually see the whole thing going round and round. Let's examine this. Oh, by the way, if you are working in the MQTT space, do use this tool called MQTT Explorer. It's super handy. I found it really, really useful. As a beginner in the MQTT, I find this extremely beneficial. So let's have a look at this. So everything that I'm talking about today is actually present in this particular GitHub repository. The link to this repository would be there in the slides later. So what I have already done the setup part. Let's look at the simple application for. I've already finished with the setup part. Let's look at the basic MQTT demo. So as I mentioned, I have a sample sensor, which is a virtual sensor. So I'm just going to, it's a Python script. So I just run it and it's running in background. Let me just look at it for a bit to make sure that it's actually working. Yeah, it seems to be running in the background. Now, I am going to run the display module here. And right now it says that my my sensor or my 5432 is off. Yeah. Let me go and look at the MQTT Explorer just to make sure. So this MQTT Explorer is connected to the same MQTT broker. And it says, hey, you have one sensor that is connected and its state right now is off. Yeah. Now, what I'm going to do is I'm going to very quickly go and turn the state on. What I'm expecting is here in the display, I'm expecting an on, and also here, this should show up as on. Well, rather than using command line, I could actually try and send the same message from here. So let me do that. So when I turn it on, a few things happened. First, this sensor, it changed from on to off, sorry, off to on. And here you can see I got a little on here. I can repeat this. Let me try and make it turn it off. And there, the sensor state is off. Here I got off. If I try to send the off twice, that's okay. I actually am not going to really make a change on the state because it's the same state. Yeah. So this is a very simple way of testing out any MQTT application. The good thing is a lot of messaging systems, especially Kafka, has a connector which can consume data off of this and put in itself. And if you look at it, there are synergies, right? MQTT is based on publish, subscribe. It has topics. Kafka has a similar model. So there's somewhat of a one-to-one mapping between the two. Yeah. So this was the simple MQTT demo. that I wanted to show you, just to give you the feel of what it looks like. Going back to the presentation. So the simple architecture is good, right? But it's not really great for when it comes to large enterprises. If you are a company who's actually investing into the IoT technology for some business function, you would want to have the data security, the data retention capabilities, and all those things in mind, right? And that's where you need to think of it in a slightly different manner. So if we think of the entire architecture in 4 layers, user interface, processing, and the data, let's actually imagine, try and understand what goes where in this architecture. So at the edge or the remote location, you have the user who's consuming your services. In the edge, you typically have the sensor or the sensor hubs, which are emitting out the events to the MQTT broker. And this MQTT broker also has maybe connected to an edge processing unit. So this is your typical in-vehicle display and things like those, right? And then you may have many such edge locations. That is like the tip of the iceberg. And now let's look at the iceberg. So you have your cloud or data center where you're actually doing all your processing and giving out the great experience to your customers. So how do you actually fetch the data from the MQTT? You have some sort of MQTT connector. It could be a program. It could be something that you write yourself. It could be like a Kafka's MQTT connector. It could be a variety of things, actually. Its sole job is to actually get messages from the MQTT broker and give it to message brokers and vice versa. The message broker now becomes the sort of gateway convergence point for all your IoT messages. There are some real-time message processing modules which are attached to it to provide some level of windowing or aggregation functions and things like those. Yeah. Now, message brokers, they are good for actually processing data in real time. But when you want to retain the data and you want to have action on the data, you want to store the state of it, you obviously need a database. And that's where a database connector will typically fetch the data from the message broker and put it in the database, and vice versa. Like through the CDC capturing capabilities of Yugabyte, you can even do the reverse. So when you make a change on the database, the data can actually be carried back to the message broker and sent to the MQTT broker and to the sensor. So you can have a full round trip there. Now, typically from a database, you would have archival jobs that will pick up all the data and put it in a data warehouse for long-term retention. And this is where you can actually run AI ML functions or processing functions which will take into consideration years of data for actually coming up with the models. And these models can actually be used within your edge processing or real-time processing systems. Also, you can have a monitoring collector that fetches all the monitoring information and passes it to a monitoring and alerting system. So this could be based on certain gauge-based metrics or some counter type metrics and things like those. Now we come to the key area of the user experience, and that begins with the API. So typically on top of the database, you would have your API, which is supplying data and collecting actions from administrator portal or consumer portals, right? And consumer portals are something that your own consumers, your customers are actually using for interacting with the whole system. Even the embedded UIs could depend on this API, depending on the use case. And most importantly these days, the mobile application. So typically the mobile apps will go back to the APIs to get the right information real time and also provide the user actions. Now, as an enterprise, what you require is this entire stack to be resilient, right? You want each of these components to be highly available, right? Any processing component has to be microservices based. You should be able to actually change it without taking down any other part of the system. Because again, as you learn from the data, your processing requirements keep changing. So you want the ability to quickly make changes and replacements into it. It should be scalable. Your database, your messaging layer, all these things should be scalable. You should be able to scale them up or out, right? And last, but the most important one these days is the ability to geo-distribute your data. This is not just for providing a better experience to your customers, but also in some cases, it might be a legal requirement for data residency purposes. So especially the PII data, you need to make sure that they are living within the geographic boundary of certain region. So now, if I go back to the architecture that we were discussing earlier, it's not like I'm not using any industry standard terms. This is like pure my interpretation of everything, right? So, but this is something that you might be more familiar with, things like Kafka, Spring Cloud, Spring Boot, right? So when it comes to the UI, you are using technologies like the web technologies. On the mobile side, you have Android and iOS. When it comes to the processing of the data, you have things like Kafka Connect or Kafka Message Broker. You have KSQL for some sort of real-time processing, and Spark for also real-time processing. The APIs could be built in a ton of these technologies, right? Go, Java, .NET, Python, PHP, anything really. But the central source of truth is the YugabyteDB in this case. Why? Because all the criteria that we saw earlier, YugabyteDB fits perfectly in all those criteria, because that's where your data is actually really resting. So, and of course, for monitoring, you can be using things like Grafana and Wavefront. Excellent tools. Then this picture, this picture is quite big. Like it's very chaotic. So let's try and focus on something that we can actually see for ourselves, right? Let's focus on this one little sort of a reverse L or J, whatever you may say. And very specifically, we'll focus on point technology. So we'll think of like Bootstrap for the UI layer, Spring Boot for the APIs, YugabyteDB for the actual database, and Kafka for the real-time data movement, right? So let's look at a demo application. So this application is an IoT fleet management application. Every vehicle is fitted with every vehicle in your fleet is fitted with a GPS sensor, and the GPS sensor data is getting collected, and through MQTT, it gets sent over to the Kafka, right? And from Kafka, through some real-time processing in KSQL and Kafka Connect, the data actually reaches YugabyteDB. And from here, the web front end, which is, in this case, it's a dashboard that could be consumed by administrators or other service owners, which is written in Bootstrap. Yeah, this the application is actually open source, so you can go and try it. Let's actually have a look at it now. So this is what the sample payload that actually comes from the vehicles looks like. So it has a vehicle ID, vehicle type, the route on which it is. It's sort of a geolocation in terms of latitude and longitude, and timestamp when the data actually arrived, and what's the speed and fuel level of the vehicle, right? So for this demo, I've already done this part. I've done everything that is before this point, so we don't have to do it again. So first thing that we are going to do is we are going to create the tables that are required for my application. So for this, I have, let me close this. Let me close that. So for this, I have all these scripts, all these SQL statements, which are in this particular SQL file. So I run this, and it actually creates the tables. There are 4 tables. One is for all the data. Let's just quickly describe the key space that it just created for me. So one is total traffic. which is based on the route. What is the traffic that is on that particular route? So this is more aggregate information. The origin table is the raw data coming from the sensors. The window traffic is a 30-second window for all the traffic on a certain route. It gets refreshed every 10 seconds or so. And then you have a POI traffic. This is a sample for if you're interested in a certain location, what's the distance of every vehicle from there? There's actually a nice UI that we can use for understanding this better. So I'm going to go ahead and start the dashboard application. So this is a Spring Boot application. So it just starts with a simple java -jar command. And it takes like maybe a second or two to bring up this whole thing. And because it's Spring Boot, it should actually run on port number 8080 very quickly. And right now it's empty because we just created the database, right? There's nothing in the database. So how do we actually put data into the database? We leave this running here and we'll open a new tab. Okay. And now, as I mentioned earlier, all these things, the Kafka and the KSQL and the Kafka Connect, there are a few things that have to be set up. So I have actually codified all of them into this script. So when I execute this, it will go and first of all create a topic for me called IoT data events. This is where all the events will actually arrive. Then the next thing it will do is it will actually create the KSQL tables and streams, which are used for all sorts of aggregation functions for real-time data. And then what it will do is it will go and create the connectors for taking all the data from the topics and putting them into the Yugabyte database. It uses the Yugabyte Kafka connector. And yeah, this should be okay. Now this is all completed. This is good. The next thing that we will see is right now, still, you don't see any data here, right? Nothing whatsoever. Next, what we need to do is now I become the driver. I'm going to drive a lot of vehicles now. So this is just a sample data producer. It will actually produce all those data. And within seconds, we will start seeing all the data actually traversing through the entire system and arriving here. So right now, what we see is the vehicle on the like total vehicle on a certain route, and then we see total number of vehicles. The POI, I guess the randomness is not producing the POI data right now, but as you can see that the data is very nicely flowing through it. Yeah, we start seeing some points here. So if we give it a couple of minutes, we would actually see more and more vehicles based on the point of interest that we have. So this actually shows how easy it is for you to have a highly scalable and distributed system, not just for messaging, but also for your database, right? Just going back, just in case if you're interested, these are the three sort of random locations in US which are being used for producing this data. And if you want to see like what's the total amount of data that is produced by far, let's just run this. And right now, total we have about 98 records that have been generated. 15 of them are probably in the POI space and so on and so forth. Yeah. Okay, so this was the demo that I wanted to share with all of you. Going back. So in summary, I have like a minute or so left, I guess. So in summary, the IoT ecosystem is changing rapidly, and the data that is getting produced, it is also going to not slow down. It will only get more. So that's why having a distributed SQL as part of your IoT ecosystem is the right architecture to work with. It actually complements the messaging nature of the IoT ecosystem very well. As you will progress through your IoT journey, you will find that you'll find yourself in the middle of a lot of these data segregation issues where you have the PII and non-PII data. YugabyteDB is able to actually handle those kind of scenarios very well. So that is why it makes it the perfect combination for the IoT use cases. And last but not the least, you can just start small and grow big because it's able to scale as per your requirement. So with that, thank you very much actually for attending the talk today. And I'm happy to take questions.